In front of us is the diagram that shows three cables. There's the first cable, there's the second cable, and there's the third cable. All those cables act as an anchor of the air balloon positioned at point B. So the air balloon is positioned at this point here. So the air balloon is actually somewhere here. That's where the air balloon is positioned. Okay. Lengths of PB and PQ are the same, so it's indicated in the diagram that PB and PQ are the same. So that tells us that BPQ is an isosceles triangle, and I can straight away from there make this angle equal to 35 degrees, and at the same time make angle B there equals to 110 degrees, straight from that information. Right. The next piece of information that is very important for us is that PB, PQ are the same, and then PQR are in the same horizontal plane. So the shaded part of the triangle is on the horizontal plane. So we know straight away that we are dealing with a 2 or 3D shape. But in this case here, we are dealing with a 3D shape because we are dealing with a horizontal plane and a vertical plane. Okay, all other angles are indicated here, 68, 42, and 35. They all are indicated on the diagram. Okay, what else can you add on this diagram? We can also add that angle R on the horizontal plane. Angle R on the horizontal plane is also 70 degrees. Why? Because it's 180 minus 68 minus 42, and that should give us 70 degrees. Okay, now let's look at the question. The first question, determine PRQ with reasons. Where is angle PRQ? Angle PRQ is that angle there. Angle PRQ, that angle there, that we've already indicated that the size of that angle is 70 degrees. So our first answer is that PRQ is equal to 70 degrees, and our reason is angles in a triangle. Let's look at the second question. The second question is that show that PQ is equal to PR sine 70 over sine 42. Right. So let's look at PQ. Where is PQ? PQ is there. And 70 degrees is there. We've already indicated 70 degrees. And PR is there. And then 42 degrees is there. So what does it tell us? That we need to use triangle PRQ to answer the second question. Now, what do we do to answer this second question? We can see that we've got sine 70, sine 42, so we need to set up an equation using the sine rule. Right, what does the sine rule state for us? We know that we need to solve for PQ, so we'll go PQ over an angle opposite PQ, and opposite PQ is 70 degrees, sine 70. There's the angle opposite PQ. There's PQ there, and there's the angle opposite PQ, equals to, our question has got PR, so we need to write PR now. PR over which angle is opposite PR? 42 degrees is opposite PR, so sine 42 degrees. And the next thing is to solve for PQ, cross multiply there, then our answer is PQ is PR multiplied by sine 70 over sine 42 degrees. And we have shown that PQ is equal to PR times sine 70 over 42 degrees. That's our second question. We'll go to the third question now. Third question, we need to determine the value of PBQ. Where is PBQ? PBQ, we have P, we have B, and we have Q. And we already have indicated that PBQ will be equal to 110 degrees. Okay, so the first thing we will write is that angle BQP is equal to 35 degrees. The reason is that PBQ is isosceles, or angles opposite equal sides. Angles opposite equal sides. Okay, so therefore angle PBQ or BPQ or BQP, what is that? It's PBQ. So PBQ and PBQ is equal to 110 degrees, and the reason is angles in a triangle. So we've answered that question. Let's go to question 4. Question 4, we are asked to show that PQ, yes, PQ is equal to PB times square root of 2 minus 2 cos 110. Okay, if we look carefully at this equation comes from the cosine rule. Alright, cosine rule states that a squared is equal to b squared plus c squared minus 2bc cos a. That's our cosine rule. Now we need to write this rule here in terms of what is given to us. Okay, now we know that we need to include side PQ. Where is PQ? There is PQ. Alright, we need to include side PB. Where is side BP or BP? And there is that. So what triangle are we going to use? We are going to use this triangle. Okay, in this triangle, please remember that this side equals to that side, and that this is 35 degrees, and that is 35 degrees. Okay, now to show that PQ is equal to that, what do we do? Where is PQ? PQ is down here. It's the bottom part of the green triangle. So PQ square is equal to, these two sides will be our two sides where 110 degrees is included. So it will be PB squared PB squared plus PQ squared minus 2 times PB times PQ times cos of A. The only angle that is included between the two sides is 110 degrees. Okay, but if you look carefully at our equation that we're supposed to prove, it doesn't have PQ. The PQ we don't have in this equation. So whatever we have for PQ, we need to replace it with PB. Why can we replace PQ with PB? The reason is that PQ, there is PQ there, is the same length as PP because we were given that. So wherever I see PB or wherever I see PQ, I will write PB because PB is the same as PQ. So to carry on with our question, the PP remains, and this PQ I will change it to PB. Why? Because PB is the same as PQ, and minus 2 then PB times PB cos of 110 degrees. Okay, let's simplify that. PB squared plus PB squared will give me 2 PB squared minus PB times PB is PB squared cos 110 degrees. Now, if you look carefully, we need to get a common factor here. Where do we get a common factor? We get a common factor because this term has got PB and the term has got PB. So we take PB out as a common factor, and what will remain behind is 2 minus 2 cos 110 degrees. Okay, remember that we have PQ squared on the side. So PQ squared is on the side, and then we put a square root here, and the answer is PQ. And we put a square root on the right hand side. We put a square root on PB squared, and we put a square root on 2 minus 2 cos 110. Square root of PB squared is PB multiplied by the square root of 2 minus 2 cos 110 degrees, and we have proved what we are asked to prove.